Hi everyone, it's Mr. H here. We're going to review linear systems in this video. We're going to look at graphing, elimination, and substitution. We're even going to look at a word problem at the end. So let's look at linear systems. The first question that we're going to look at says this: solve the following system of linear equations graphically and using the substitution method. Now you'll notice that we have two equations there, and you'll notice that the first is in the form y equals mx plus b, where that slope, m, is -3/2. The y-intercept is 5. To graph that, we start with the y-intercept, so we go to 0, 5, and then we go down 3 and to the right 2, down because it's -3. We go that and we continue that pattern, draw the line through those points, and we label that with the equation. You'll notice the second equation is not in the form y equals mx plus b, so what we're going to do is we're going to rearrange that equation so that we can actually go ahead and write it in that form. If I add 1/2 x to both sides, it cancels off the right side, and I'm left with y equals 1/2 x minus 3. And so we go ahead again, recognizing that the 1/2 is the slope, the -3 is the y-intercept, and so we start with the point 0, -3. We plot that point first, and then from there, we go up 1 over 2, up 1 over 2. We're always going over to the right. And so we plot a number of points, draw the line between those points, and label it with the equation. And we can see there that the solution is going to be at 4, -1. So we've done it graphically. Let's talk about the substitution method. So we're labeling the equations 1 and 2. And we're going to take that first equation because y is already isolated, and we're going to substitute everything that y is into equation number 2. So where we had the y, we're going to put -3/2x plus 5, and then we're going to continue equation 2 with minus 1/2 x equals -3. So we've substituted equation 1 into equation 2. And now what we want to do is we want to get the like terms together. So we want the 5 and the -3 together. We're going to get that together by subtracting 5 from both sides. It's going to cancel off the left side. And then we want the x terms together. -3/2 minus 1/2 is -4/2. And then -4/2 is just -2. So we get -2x equals -8. And we divide by the coefficient, which is -2. That cancels out, giving us x equals 4. Now we're not done yet because we now need to substitute that x equals 4 into one of the two equations. It's easier to sub it into one because y is already isolated. So I'm going to write y equals -3/2 times 4 plus 5. And now I'm going to just go -3 times 4, which is -12/2, plus 5, that's -6. -6 plus 5 is -1. So our solution for this is the x term first, followed by the y, 4, -1. And we say, therefore, the solution to the system of linear equations is that. You'll notice that's the same point we have on the graph as well, 4, -1. That's exactly what we did graphically. So both of them produce the same answer, which we want. Now we look at the elimination situation. It says find the point of intersection using the elimination method. We have two equations, and you'll notice that none of the coefficients are the same. We want one of the coefficients to cancel when we either add or subtract the two equations. So what we're going to do is we're going to multiply that second equation by 2 in order to have the same coefficient in front of the b term. So that's going to give me 16a minus 4b equals 14. I'm going to bring the first equation over, keep it the same. And so now what you can see is I have a 4 in front of the b, and then in the second equation I have a -4 in front of the b. So because of that, I'm going to add the two equations, 10a plus 16a, the 4b plus -4b, and the -1 plus 14. And so what I get when I add all those together, I get 26a equals 13. And so I divide by the coefficient in front of the a term, that's 26. And I get a equals 1/2. 13 divided by 26 is exactly a half. So now what I need to do is I go back to the substitution method for this piece of it, and I just substitute a equals a half back into one of the two equations. I'm going to choose equation 1. And so I'm going to get 10a, a is a half, so I'm going to sub that in, plus 4b equals -1. 10 times a half is 5. 5 plus 4b equals -1. I want to bring the 5 to the other side to get the b by itself. So I get 4b equals -6, and I divide by the coefficient in front of the b term to get -6/4, which simplifies to -3/2. So that's my solution to that system of linear equations. And if I was to graph this with the point of intersection on a graph where we have a as the x-axis and b as the y-axis. So therefore, the POI is 1/2 -3/2. Now it then says to check your answer algebraically. And so what we're going to do is we're going to start by looking at equation 1. and we're going to go, the left side is 10a plus 4b. We keep the left and right side separate, and we then go and we substitute the a value and b value into a and b. So 10 times a half plus 4 times negative 3 over 2. We go ahead and we multiply the coefficients. So 10 times 1 is 10 over 2. And then 4 times negative 3 gives me negative 12, which is over 2. And that gives me 5 plus negative 6. And then 5 plus negative 6 is negative 1. And so we can say, therefore, the left side is equal to the right side. So we know it works for that first equation. But we haven't checked the second equation yet. So let's check that one as well to see if it works for that as well. So what we're going to do is we're going to, again, separate the left side and right side out. And we're going to substitute a and b in for the variables. So in the place of a, we have a half, and in place of b, we have negative 3 over 2. Doing the same thing as we did before, 8 times a half gives me 4. Negative 2 times a negative gives me a positive, and so it ends up being 3. And so 4 plus 3 is 7. The left side is equal to the right side, and we can have confidence that we got that answer correct. It is, in fact, a point of intersection of a half and negative 3 over 2. Number 3 says this. The admission fee for a virtual rock, paper, scissors competition is $1.50 for youth and $4 for adults. This past year, 2,200 people entered the competition. The money collected from the competition was $5,050. How many youth and how many adults entered the competition? First thing we need to do is we need to actually define variables here. And so we're going to let A be the number of adults who participated. And so if A is the number of adults who participated, then Y would be the number of youth who participated. And so the reason that we always define it as a number who participated in is because it allows us to find what it's asking in the question. It's all about defining what was asked in the question. The question is there at the end. And so we have $1.50 for youth, and we have $4 for adults. 2,200 people competed, and we raised $5,050. So we're going to start with the most obvious equation, perhaps, and that is the fact that if we had 2,200 people, if we add the number of adults plus the number of youth, it's 2,200. But then we also have the total amount of money that was brought in. And so that looks at $1.50 for youth, so 1.5 times Y, and then $4 for adults, so 4 times A, and they brought in $5,050. And so I've written that just so that the A's are together and the Y's are together because I'm going to use the elimination method here, just like I did in the last example. So I multiply the first equation by 4. I get 4A plus 4Y. And then the A's are going to cancel when I go ahead and I subtract the one equation from the other. So remember, I had to multiply that entire equation by 4. So I subtract the two equations. 4A minus 4A gives me 0A. Now we go 4Y minus positive 1.50Y. We also make sure we 8,800 minus 5,050. Don't forget to subtract all the terms that are below it here. So we get 2.50Y, and 8,800 minus 5,050 gives me 2,950. So 250Y equals $2,950. I divide by 2.5. Whatever you do to one side, you have to do the other. That's going to cancel out the coefficient in front of the Y. And Y equals 1,500, which means that we had 1,500 youth attend. Now, you could probably just think if we have 2,200 and 1,500 youth attend, then that means 700 adults. But if you want to go back to the algebra of it, you could do that as well. And the easier equation to sub that into to solve for the A would be equation 1. And so that's why I've substituted that into equation 1. The number of adults plus 1,500 equals 2,200. If we subtract 1,500 from both sides, we get the number of adults equals 700. Therefore, 700 adults and 1,500 youth attended. If this has been helpful, please like and subscribe. For more on solving linear systems graphically, click the video on the right. See the grade 10 math playlist on the left. It will continue to be added to until all review videos from the course are complete. Thanks so much for watching.